Hi, welcome to my video on graphing exponential functions by transformations, part 1. The exponential equation is f of x equals a, b is the base, c bracket x minus h plus k, where x, a, c, h, and k belong to the real numbers, and the base, which is right here, the base is greater than 0 and not 1. When I do reflections, and most books, we think of reflections as being RST. That's reflect, stretch, and translate is the order that I'll be using on the transformations. And R stands for reflection, and we reflect in the y-axis. And when we reflect in the y-axis, that means the C value that's going to be right here is going to be negative. So that means if you have a graph, which is a growth, like that, and I'll always reflect from a growth graph, always start what happens to B is greater than 0. Sorry, B is greater than 1 on a growth curve. If that's a growth curve, which is going to the right, up, x is going to infinity, y is going up, then the reflection of that in the y-axis is like this. So that's the reflection. So that's when the c is negative. And it reflects in the x-axis. So if you take the same graph again, which is a growth curve like this, and if we take this graph, and a, which is the number in the front of the base, if that a is negative, then this graph will reflect, and it will reflect like this, going down, because it's reflecting in the x-axis. So imagine you just take this graph and reflect it over here. So there it is there when you reflect it, and that's when the a is negative. And S stands for stretch, and the stretch got to be positive. Stretch is never negative, it's got to be positive. And the stretch is the horizontal stretches in terms of the x, so the number in front of this bracket is whatever c is, then the stretch is always the reciprocal of this stretch. And you'll see that going on. And it's the absolute value of it, because the stretch is always positive. And the vertical stretch is the absolute value of the a, which is in front of the base. And it's absolute value because it's always positive. And T stands for translation, and we got a horizontal translation, which is the H. But so whatever, we got an X minus H, so H is the stretch, and the stretch, whatever this sign is here, is always the opposite of this sign. So X minus 2, stretch would be 2. X plus 2, the stretch would be negative 2, because it's always the opposite of this sign. We think about it. And the vertical stretch is the K, and the vertical stretch is related to the asymptote. So the stretch is, this is a plus 3, then it's gone up 3. If that's a minus 3, it's gone down 3. So to start this off and to make it okay, because some students have trouble with transformation, but let's see if we can do it correctly. There's an A, B, C, H, and K. A is 6, B base is 2, C is negative 4, H is, and we take the opposite of that, which is 1, and 3 is the value of K. So notice we do the opposite of this. So the H is the opposite of X minus 1. And let's look at this one. A is negative 9. B is 3, base is 3. C is 1, there's no brackets, so it's understood to be a 1. H is minus 2. And K is 4. And in this one, A, there's a 1, understood. A base is half. C is 4. Notice there's no bracket, so H is 0. And the K is negative 1. And in number 4, A is negative 2, base is 4/7. C is 3. Opposite of +6 is a -6. And K is -5. So that's picking out the values of A, B, C, H, and K. Okay, so let's look at the transformations of the equation now. I have an equation here, so I want to help you line up the stretches and what they are, the fractions, the stretches. So notice I have R, S, T, like in the alphabet. R, S, T is the order of the alphabet. It's to reflect, it's a stretch, and it's a translate. So when we do a reflection in the y-axis, that's when C is negative. So the value of C right here is C is a +1. That means because it's a plus, that means there's no reflection in the y. A reflection in the x-axis is when A is -4. A is -4. Because A is negative, then there is a reflection in the x-axis. And the horizontal stretch has to do with the value of C, which is right here. Again, C is 1, so the horizontal stretch, really, when there's a 1, we have no horizontal stretch, so the graph stays as it is in terms of horizontal. So in other words, the numbers. So if there's a gap, if the numbers go from 1 to 2 to 3 to 4 for x, then the stretch is 1. If the numbers go from 1 to 3 to 5, then the stretch is 2, or the numbers. So there's a 2 gap, but exponential behave different. So there's no horizontal stretch. And the vertical stretch is the value of A, but the vertical stretch has to be the absolute value of A, which is the absolute value of -4. So the vertical stretch is a 4. But it's always has to be positive. So the y values are stretched 4 times more than they are in the basic graph. And the horizontal translation, that means that horizontal translation, if we look at it, H is 2, so the horizontal translation is 2 right. And the horizontal translation is opposite of this, so the horizontal H is 2 because it's the opposite. So when you put 2 in here, 2 in the place of X, you get a 0. So when that becomes 0, that's your horizontal translation. But it's the opposite of the number, that's with the X right here. And the vertical stretch is, K is 6. So your vertical, I said vertical translation now. Vertical translation is 6, but it's up. Notice horizontal translation is right and left. Right is positive, left is negative. The vertical stretch is positive, it goes up that many units. And if it's negative, it goes down that many units. Okay, now if you're familiar with what to do, pause your video and see if you can work each of these out. Here we go. The y value is reflection. Reflection on the y-axis. So reflect in the y-axis, we look at the value of C. So C is 2. And as a result of 2, it's positive, so it's no reflection. And the reflection in the x-axis is in terms of A, and A is 1. A is 1, 1 is right here, so there's no reflection in the x. That means, let's look at the stretch next. So remember, it's an RST. So stretch, the horizontal stretch is in terms of the C. So again, the C is 2. Is in terms of the C, horizontal stretch, is in terms of the 2 right here. So C is 2, but the stretch is 1/2. It's always the reciprocal of this number. And the vertical stretch is the value of the A. So A is 1, so the absolute value of 1 is 1. So the there's no vertical stretch, no change. And the translation, the horizontal translation is in terms of, notice that the h is equal to -1, always the opposite. So that means it's gone, horizontal is left and right, because it's negative is gone one left. And the vertical translation is in terms of the k, so k is -3, so that means it's gone, vertical is up and down, so it's negative, it goes 3 down. That's 3 units down. And we'll do more on that when we do the graphing. Number 3, let's go through it all again. Again, the reflection in the y-axis is when we look at the c value. So the c value is -1. So because it's negative, yes, it's reflected in the y-axis. The reflecting the x-axis, we look at the value of a. So a is a half, positive, so there's no reflection in the x-axis. Again, when you reflect in the y, you're looking at the x. When you're reflecting the x, you're looking at the y. Think about it that way. And we have a horizontal stretch. We're looking at the value of c. So the value of c, absolute value of c, is the absolute value of -1, which is 1. So there's no horizontal stretch, because it's only a 1. And the vertical stretch, we look at the a value. So a is a half, so the absolute value of a half, the stretch is a half. So the horizontal stretch looks at this number here, absolute value. The vertical stretch, notice the half is times this, so it's, and the vertical, I was going to look at the 1 then. When you did reciprocal 1, it doesn't change, so it changes from the basic. Translation is horizontal, and we're looking at the value of h. So we look at this equation, the h is 4. Always the opposite. So it's 4, so it's gone 4 right. And the vertical translation is the k. So the k, there's no k there, k is 0. So there's no up or down. It stays in terms of the x-axis. It doesn't slide up or down. And number 4, in terms of the y, we're looking at the c value is 1/4. Looking at the y, we look at what the c is, 1/4. And because it's positive, then there's no reflection in the y-axis. Now we look at the a is -1, right here, a is -1. So that means because it's negative, it's reflected in the x-axis. And the horizontal stretch is when you have the c is 1/4, and so it's the reciprocal, so the stretch is 4. The vertical stretch is a is the absolute value of -1, which is 1, so there's no stretch. When you have a 1 for stretch, it's not changing the basic equation from the basic equation. Remember, the basic equation here is y equals 2 to the x. The basic equation here is y equals 7 to the x. The basic equation here is y equals 5 to the x. The basic equation here is y equals 3 to the x. So the base to the x power, with everything being 1s, is, or not everything being 1s, but when there's no, when you, basic equation is y equals b to the x, where if you have y equals b to the x, then you look at a is 1, you look at c is 1, you look at h is 0, and k is 0. So that's the basic equation. So the basic equation here would be y equals 10 to the x. And so when we graph with transformations, we have to look at the basic equation and then graph it according to the mapping rule. We'll do more on that coming up. The horizontal translation is when you have, notice you have no brackets, So that means h is equal to 0. So we have no horizontal translation. And we have h is equal to, or sorry, k is equal to 1. So it's gone 1 up, because it's translated plus 1 is 1 up. Number 5, again, we're doing a reflection in the y-axis. So c is equal to -6. Because it's negative, it's reflected in the y. We look at the a is 3. The a is 3. There's a c, I forgot to point out. C is right here, -6. Because it's negative, it's reflected. A is 3, and because it's positive, there's no reflection in the x-axis. And a horizontal stretch, it says c is -6. So we do the absolute value of that. So we get 6. So the horizontal stretch is the reciprocal of 1/6. It's always the reciprocal. And the vertical stretch is, A is 3. So the absolute value of 3 is 3, so the vertical stretch is 3. And the vertical translation is in terms of h is, again, opposite of this one, is -2. So it's gone, if you think about it, stretch 2, horizontal left and right, negative is to the left, so it's gone. In terms of the basic equation, which is y equals 10 to the x, this graph has moved 2 units. All points have moved 2 units to the left. And k is -7, so it's gone 7 down. Again, the vertical translation is up and down. If it's negative, it goes down. If it's positive, it goes up. And one more in this chart. We reflect in the y-axis is when we have, it says that, oh, notice I have no bracket. So that means I got to rearrange the equation. 2, I have to take the -3 out, and it has to be factored. -3x divided by -3 is x. 3 positive 3 divided by -3 is -1. I need a bracket here on this expression. Now, I can say c is -3. That means it's reflected in the y-axis because it's negative. A is 1, so there's no reflection because it's positive. And the horizontal translation is that the absolute value of c is the absolute value of -3, which is, make it 3, and so it's reciprocal. So it's the reciprocal of the it's the absolute value, which is 3, but the reciprocal of 3 is 1/3. And the vertical stretch is absolute value of 1. There's a 1 here. The absolute value of A, absolute value of 1 is 1. So that means there's no stretch. And translation, notice I had to take it, factor out the -3. So now I'm looking at h is 1. So that's why I had to factor out the -3 to get this bracket. So h is 1. So that means it went 1 right. Horizontal is left and right. Positive goes right, negative goes left. And k, there's no value of k here, so k is 0, so there's no vertical stretch. Okay, hopefully it makes sense, but if you keep thinking about it that way, and rough to do, but you just got to keep thinking in as I'm trying to show you here. And notice with the x, I just want to point out something. Notice with the x, this is 1/4. You get a reciprocal. And notice when you, like we have a -6 here is 1/6. We have a -3 here. We have a 1/3 because the stretch, horizontal stretch is always positive. But in terms of x, notice also, this is in terms of the stretch, which is reciprocal of 1/6, but it's the opposite of +2, which is a -2. So in terms of the x, it's the reciprocal of this one, and it's the opposite of this one. But in terms of the vertical, it stays 3 as a stretch, and it stays -7. So in terms of the y, the stretch is 3 and -7 is the translation. But in terms of the x, it's the reciprocal and opposite. We'll do more on that as we go. Write y equals a times b, c times x minus h plus k for each. Notice the basic equation is y equals 2 to the x. So what do we write? We gotta have y equals 2 to the x. So let's look at the reflection in the x. And the reflection in the x, when you reflect in the x, you're looking at the a value. So that means you reflect in the x, that means the a value is negative. So that means I can put a negative here. Now I have a horizontal, I have no vertical stretch, so the a is 1. Horizontal stretch, a horizontal stretch is in terms of the c. So if the horizontal stretch is 4, that means the c in the equation is 1/4. So the c goes right here as 1/4. And there's no horizontal translation, so that's just an x. And it's moving 3 up, so that's the k. So that means the k is 3. So it's just a +3. So that's the equation, the basic equation. The base is 2. So the negative on the a means it's reflected in the x, is going downward, reflected down. And the horizontal stretch is reciprocal. And the translation 3 units up stays positive. So there's the equation. And don't forget, you can pause your video at any time. The equation is, we got to have the base is 2 because it's out of this equation here. Reflected in the y, reflect in the y, then that means you're looking at the c. So reflect in the y, it's going across like that, so you're changing the x. So you're looking at the c, which is the x. The c is, let's put an arrow on that, the c is negative. So that means this is the negative. Because reflected in the y, the c is going to be negative, and the c is right here. We got a vertical stretch of 5, so that means that a is 5. So 5 stays like that, because a is 5 right here. And it's moved 2 units to the left, so that means 2 units to the left. That means that h is -2. To the left and right is the value of h. Because it's to the left, it's -2. So that means we have no horizontal stretch. The horizontal stretch is just 1. So we have h is -2, so that's x plus 2. So there's the equation. And we do not have up or down, so we have no value of k in here. K is 0. And c, again the equation, y equals base is 2. So the base is 2, a horizontal stretch of 1/3. So that means c is the horizontal stretch, and it's the reciprocal, so it's a 3. So it's a 3 with the x. And it moves, and there's no, it's moved 4 units right. So that 4 units right means h is 4. So that means we have an x minus 4 in the equation. And 6 units down, it means k is -6. So we got a -6. So notice, everything fits. We have no reflection. We have no reflection in the x-axis because we have no reflections at all. So a is not negative or c is not negative. We have a horizontal stretch which affects the x, reciprocal, and you can see opposite of 4, -4, and the 6 stays as a minus. And D, reflect in the x-axis and the y-axis. So let's see. Reflects in the x and the y. So the a is negative and the x is negative because both of them are reflected in both axes. We got a vertical stretch of 2/3. The vertical stretch means it's affecting the a. So 2/3 is with the a. A is in front. And 2 units up, that's units up, that's affecting the k. So up is plus, so that's a +2. So that means we have Nothing to go with the x. We have no horizontal stretch. We have no horizontal translation. So just a negative x, and the 2 goes in the place of k. So that's just a little bit of practice there, but that takes time to get used to. A lot of practice. And this is true for all graphing. If you graph parabolas, if you graph logs, exponentials, if you graph any graphing that you do, square root equations, cubic, when you think about the transformation on different functions. And that brings us to the end, but there's more videos coming on transformations. If you like my video, click the like button. Click the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.